Okay. All right. Yeah. So, a little disclaimer starting, I guess, coming from the design world. So, I'm going to be talking today about how this data can potentially be used in solving urban planning and design problems, making better spaces for people to live in, that kind of thing. So, it's really going to be leading up as a series of trends that I'm seeing kind of in the data world, and maybe into more specifically some of the projects that I'm currently engaged in, developing pretty intensely, and I'm starting to develop those further in a new position that I'm starting next week at Skidmore, Owings & Merrill, architecture firm, if anyone's familiar, kind of on the engineering side, but you know, it all mixes together in some ways. So, first of all, cities are complex systems. I think we all know this. What many people don't realize is the means of managing this complexity are not yet being utilized to the fullest extent. Great. Why is this a problem now? Because we're getting global urbanization happening faster than ever before. So behind me is a picture of Kuala Lumpur, Malaysia. You know, in the last 50 years, it's grown incredibly. My favorite examples here is Shanghai, 1950-ish, 29% of people. This is the central business district that you know of today. So fast forward to today, and you know, it just goes from like nothing to craziness. And
there's actually a good time lapse out there of this. You should do it.
I gotta get that. Thank you for that. And this is expected to grow further. So it's not. This is not a unique situation. In other continents all over the world, you know, Africa is being one of those. You're getting massive influx of people into these urban centers, and you know, there's small amounts of planning going on in a few streets, and then otherwise it's just getting inundated without central plans of how to manage those people, and that's a problem. Why is that a problem? The energy, water, waste, social infrastructure cannot keep pace with this change. So you see in the news and things the Shanghai highways that are just covered and packed with cars or waiting for traffic for like 10 hours or something unheard of in the US, but it happens. So we've all heard of smart cities. Now this is a term coined by IBM, marketed and invested heavily by IBM, so thank you for that. It's about connecting people, using the information we have available today, smartphones and all that data being poured out of there, bringing it together, making decisions off of it. This is like the solution to all of our problems, right? That's what IBM is touting it as. It's really not yet there. And there's certain things that just haven't been able to trickle down from the big like Rios or larger cities yet. So that is also changing. Sensor costs are decreasing, access to computational resources and power, cloud computing, that's all becoming very easy to do. I can jump on Amazon right now and open up a big cluster that is charging me like $1,000 an hour if I want. And I've done that before and forget it. And my employers are not happy about that. But people are more connected to than ever. Everyone has smartphones. That data is being poured. This is what is this, TI, kind of Raspberry Pi equivalent. BeagleBone, that's the name of it. That's really the name of it. There's so many of these different little open source, circuit boards basically you can take and kind of work with, put sensors on it.
Can you say that again?
This is a BeagleBone.
BeagleBone.
BeagleBone. Texas Instruments version of Raspberry Pi. But maybe Raspberry Pi is a version of whatever. Okay. So great. All these sensors and this data is being collected, stored in places. I think this is like one of Facebook's data centers, or Google's maybe. It's being openly accessible. Tom's in the room right now. He can tell you all about the Chicago data portal and the cool things people are doing with it. You're getting apps like this is Manhattan energy consumption intensity. So it's all powered by Socrata, which is a similar kind of thing, and it's happening all over the country. Cars are all being connected. Coming off these new lines now in the next few years. Each car is going to essentially have its own IP address, which is something interesting. We're going to be able to understand I'm not going to get into security issues. I'm not going to shy away from that, but it's going to be possible to make a call to any car and extract the latitude, longitude, all of the PID parameters, the sensors within the car. All that data is going to be accessible from me, typing in like a URL address to get. Maybe not that easy that I can just type it in, but that's a discussion. It'd be nice if it's all open though. Probably won't be. So anyways, a trend that I see is that a lack of expertise exists to take advantage of this data for effective change. I want to relate this to the trend in computer science about 50 years ago. Computers were emerging as a unique discipline. You know, they took up full rooms and whatnot. This same lack of expertise was there then. So what happened? Physicists, mathematicians, statistics people, engineers, all these different groups basically came together, filtered into one unique discipline, which we now know as computer science and computer engineering. You know, now you look at today, and there's a large number of jobs, and it's still a very much growing industry. And you know, full buildings are built in support of this kind of discipline. So it's like MIT's computer science strange building, right? Here, I believe. So I want to propose here that the same trend is actually happening with urban science and the understanding and taking of all this data and doing things useful with it. So there's expertise being created in academic settings. Some of them I have up here. Many of you, I'm sure, are familiar with UCCD, Urban CCD, and the DSSG group that are right here in Chicago doing awesome stuff. CASA has been around for a long time. They're based in London, you know, doing a lot of cool, more simulation-focused stuff, but they're making a lot of experts that are distributing all over the world. CUSP, this is a New York-based, like brand new arm. I think it's New York University, and they basically just, Bloomberg funded this program, and now they have a full floor, and they're churning out PhD, graduate, and undergrad students in this urban sciences realm. So the expertise is being created. I want to propose that the expertise already exists in other disciplines. So for this, we can look at modern day systems biology, because cells are complex systems, like cities. Maybe more so, maybe less so, I don't know. I'm not going to get into that conversation now, unless you want to. Okay, so modern drug discovery techniques, they use ensembles of systems analysis, algorithms come together, understand development trajectories of cells and how from a stem cell they get specialized and whatnot. They're designing these fancy algorithms to reverse engineer the networks at a gene level or a transcription factor level, and from that we can do cool stuff with it. So you look at two cell structures, for example. You have a disease cell and a healthy cell. Each one has a unique structure and then a unique way that data flows through that structure. What the upcoming systems biology is doing is actually saying that, okay, we want to take this diseased network and we want to move it to a healthy network. In order to do that, we need to hit this point, and that point with a targeted drug. And voila, it's healthy, it's cured now. This is still ways off, but that's kind of the trends going on there. So this begs the question, what's the healthy state of cities? Is there a way to somehow classify a diseased or unhealthy state within a city and move it to a healthy state? I think so. I still don't know exactly what the healthy state of a city is. This is something people write books about. Does it have to do with economy, growth potential, the pulse, activity, buzz of a city, which we can now start to measure with things like Twitter and different social networking and even cell phone activity and whatnot. Ease of flow. I think this is a big one. Just being able to move from one place to another without getting obstructed by those annoying subway turnstiles and things like that. Being able to get clean water in and out, energy sources in and out, and then accessibility to food, education, jobs, make money, etc. I don't. It goes way further than that. I'm not going to dive into it. So the knowledge for urban scale decision making all exists in academic settings. They're all distributed in these silos of information, I would imagine. It'd be nice to have it come together in one way. And some of the things that I've been working on, I think, are an attempt to make that happen. So specific solution that I'm going to start kind of showcasing, and I have some live demos too and some animations and things. It's something that I'm calling a city mirror. It's essentially a computational framework to enable informed high-impact decision-making. Right now it's all web-based, regardless of what the front-end interface would be. It's the same stuff going on in the background in terms of how the data gets fed into that interface, how the analysis occurs, etc. So what is a city mirror? It's a physical digital synthesis, a representation of that physical environment into a digital environment and being able to understand it, first of all, and then make scenario and analysis decisions from it. So it's almost like a sandbox environment for utilizing this data. And that's some of the hardest things, I think. We have all this stuff out there, and more of it's being generated. Not a lot of people now know exactly what the best use of it's going to be. And I guess I'm speaking from a planning and design world, but maybe it's more ubiquitous than that. So basically the process of developing the city mirror, and I'll show you some live examples again coming up. Basically, you take all this data in, so a lot of it's from the open data portal. The parcels, the real-time CTA transit locations, all this different stuff. I plop a user interface on top of it. I'm using Sencha Touch right now. If any of you are familiar with that, it's a great mobile app development suite framework, also open source, kind of. And then a simulation analysis piece that once this thing turns on, you can start kind of sandboxing ideas around. So you're seeing in real time, the train locations, and at some point there will be people built into this as agents. And you say if we close the road, how are people going to respond to it? All this is going to be kind of built into this. I'll skip over that. Maybe I'll just go to some live demos now.